S-type asteroids, the stony ones. The most boring name in the solar system, attached to some of the most common objects in it. Here's the pitch. Silicate rock and nickel iron metal baked and battered for 4.5 billion years, reflecting sunlight in a way that makes them look faintly reddish through a telescope. They dominate the inner asteroid belt, closer to the sun, closer to Earth, closer to everything that matters to us. There are hundreds of thousands of them cataloged. Eros, the first asteroid ever orbited by a spacecraft, is an S-type. So is Itokawa, the potato-shaped rock that Japan's Hayabusa mission actually touched, grabbed a pinch of dust from, and brought home in 2010, the first sample return from an asteroid in human history. Here's the twist. S-types aren't just rubble. Some of them are the exposed guts of baby planets that never finished forming, worlds that started differentiating into a core, a mantle, and a crust before something smashed them apart. Look closely at an S-type asteroid, and you might be looking at the inside of a planet that almost existed. That's the part that should sit with you. Every rock like this is a planet that got interrupted mid-sentence. Consider Vesta, the second largest object in the main belt. Vesta has a differentiated interior, an iron core, a rocky mantle, even ancient basaltic lava flows frozen on its surface from 4 billion years ago. NASA's Dawn spacecraft orbited it in 2011 and found something that looked less like a boulder and more like a stillborn world, complete with a crater so large it stripped away a chunk equal to 1% of Vesta's entire mass in a single impact. But stony rock is just one flavor. Head further out in the belt, and the asteroids get darker. Much darker. C-type asteroids. Carbonaceous. The most common asteroid in the solar system, and also, by a wide margin, the least reflective. Here's the reframe. C-types are so dark, they reflect only about 3 to 4% of the sunlight that hits them, closer to charcoal than stone. Ceres, the largest object in the asteroid belt and a dwarf planet in its own right, is a C-type. So is Bennu, the 490-meter rubble pile that NASA's osiris-rex mission touched down on in 2020. Here's the fact that changes everything. C-type asteroids are rich in water-bearing clay minerals and organic carbon compounds, the literal building blocks of biology. When OSIRIS-REx returned samples from Bennu in 2023, scientists found amino acids, the raw ingredients of life, sealed inside a rock that's been drifting since before Earth had an atmosphere. Let that sink in. Somewhere out there, tumbling silently through the dark, are the ingredients for you. And here's the twist nobody saw coming. Bennu has roughly a 1 in 2,700 chance of impacting Earth in the year 2182. Not tomorrow. Not in our lifetimes. But real enough that NASA tracks its orbit down to the meter. Stone gives shape. Carbon gives chemistry. But some asteroids aren't made of rock at all. M-type asteroids. Metallic. And these might be the strangest family in the entire belt because of where scientists think they came from. Here's the pitch. M-types are made almost entirely of iron and nickel, the same alloy that makes up Earth's own core. The leading theory is that they're literally that planetary cores stripped bare after a catastrophic collision blasted away the rock and mantle that used to surround them. Psyche, the largest known M-type asteroid, is roughly 220 kilometers across and estimated to be almost entirely metal. NASA launched a spacecraft named after it in 2023 on a 6-year journey to reach it in 2029, the first mission ever sent to study a metal world up close. Here's the fact that changes everything. If Psyche really is an exposed planetary core, it means humanity is about to visit the only place in the solar system where you can stand on the kind of material that sits 4,000 miles beneath our own feet, at pressures and temperatures no drill has ever survived. We can't dig to the center of our own planet, but we might be able to walk on someone else's. A rock, a chemistry lab, a planet's heart torn out and left drifting. 3 flavors, 1 shared address, the main asteroid belt itself. The main belt. Between Mars and Jupiter, a donut of debris, roughly 1.5 times as wide as the distance from Earth to the Sun. Here's the reframe pop culture got wrong. It is not a wall of rocks. It is not a field you'd have to dodge and weave through like an action movie. The average distance between substantial asteroids in the belt is nearly 1 million kilometers. If you stood on one, you likely couldn't see another with the naked eye. And yet the numbers are still staggering. Over 1 million asteroids larger than 1 kilometer are cataloged in the main belt, and the true count of smaller fragments runs into the millions more. Total mass of everything in the belt combined, roughly 4% of the mass of our own moon, an entire ring of debris spread across a region wider than most people can picture, and it barely adds up to a fraction of one small moon. Here's the twist: Jupiter is the reason the belt exists at all. Its gravity is so overwhelming that it stirred the material in that region so violently 4.5 billion years ago that a planet simply couldn't coalesce there. The asteroid belt isn't leftover debris from a planet that broke apart. It's a planet that was never allowed to be born. There are asteroid families within the belt too, clusters of fragments sharing nearly identical orbits, the leftover shrapnel of collisions that happened millions or billions of years ago. The Charon family, for instance, is believed to have formed from a single breakup just 5.8 million years ago, a blink of an eye in solar system terms. Some of that debris still rains down on Earth today as meteorites, meaning a piece of rock sitting in a museum case might be a direct, datable fragment of a collision that took place after dinosaurs had already been extinct for 60 million years. An entire population of almost planets, permanently interrupted by a bigger neighbor, but not every rock stayed in the belt. Some found a much stranger parking spot. Trojan asteroids. They don't orbit a planet. They orbit alongside one, locked into a gravitational truce with it. Here's the pitch. At 2 points along a planet's orbit, 60 degrees ahead and 60 degrees behind, called the Lagrange points L4 and L5, the combined gravity of the sun and the planet creates a stable pocket where an asteroid can sit indefinitely, neither pulled forward nor dragged back. Jupiter has the most famous population, over 1 million Trojans, larger than 1 kilometer, more than the main belt itself by some estimates. But Trojans belong to Neptune, Mars, Uranus, and even Earth. Yes, Earth has at least one confirmed Trojan asteroid, 2010 TK7, quietly riding 60 degrees ahead of us in our own orbit, a traveling companion nobody knew about until 2010. Here's the fact that changes everything. NASA's Lucy mission, launched in 2021, is on a 12-year tour of 8 different Jupiter Trojans, the first mission ever to visit these objects. Scientists believe Trojans are frozen relics from the very outer solar system, kicked inward billions of years ago, and trapped in Jupiter's gravitational shadow ever since. They may be the best preserved fossils of planet formation we have left. An asteroid that never wanders, held in place by cosmic geometry since before the sun had settled into its current shape. Some rocks stay locked in place forever. Others cross paths with us on purpose, or close enough to it that it stops being funny. Near-Earth objects. This is where the taxonomy stops being academic and starts being personal. Here's the reframe. A near-Earth object is anything, asteroid or comet, whose orbit brings it within about 195 million kilometers of the sun, close enough that its path can cross Earth's own. Over 34,000 are currently known, and roughly 3,000 new ones get discovered every year. Within that population sits a smaller, sharper-edged group, potentially hazardous asteroids. To earn that label, an object needs 2 things: a size of at least 140 meters across, and an orbit that comes within about 7.5 million kilometers of Earth's path. There are more than 2,300 of them currently tracked. Here's the fact that changes everything. None of the currently known potentially hazardous asteroids have a significant chance of hitting Earth in the next century. That's the reassuring part. The unsettling part is the phrase currently known. Astronomers estimate we've found over 95% of the largest planet-altering asteroids, the kilometer-plus objects that could end civilization. But for the smaller ones, the ones large enough to level a city, we've likely found less than half. Let that sink in. Somewhere out there, unlisted and untracked, there may already be a rock with our name quietly written into its orbit. This is why entire agencies exist, just to keep counting. NASA's Center for Near Earth Object Studies and the Minor Planet Center track every new detection, running the orbital math within hours of a discovery to calculate impact probability decades or centuries into the future. In 2022, NASA's DART mission deliberately slammed a spacecraft into the moonlit Dimorphos, successfully shortening its orbital period by 32 minutes, the first time humanity has ever proven it can nudge a celestial object on purpose. It was a test on a harmless target, but it was also quietly a rehearsal. Rocks that merely cross our path are unsettling enough, but some near Earth objects have already made contact, and the record is written into the ground itself. Chelyabinsk was the wake up call. In 2013, an 18-meter asteroid entered the atmosphere over Russia completely undetected, exploded with roughly 30 times the energy of the Hiroshima bomb, and injured over 1,600 people from shattered glass alone. Nobody saw it coming. It arrived from the direction of the sun, invisible against the glare, and we only found out it existed the moment it detonated. Here's the twist that should genuinely bother you. An object that size is far too small to make the planet killer tracking lists, and far too large to ignore. It's precisely in the gap where our search efforts are weakest. The most dangerous asteroids, statistically, aren't the giants. They're the ones just small enough to hide. Rocky debris tells one kind of story. But drift far enough from the sun, past Jupiter, past Neptune, and the story changes completely, from rock to ice. Short period comets. Comets that return again and again on orbits measured in years or decades rather than millennia. Here's the pitch. Most short period comets belong to the Jupiter family, their orbits repeatedly bent and reshaped by Jupiter's gravity until they settle into loops lasting less than 20 years. Halley's comet is the most famous exception, a short period comet, but on a longer 76-year loop, visible to the naked eye every time it swings past, last seen in 1986, due back in 2061. Here's where the science gets stranger. Short period comets are now understood to originate from the Kuiper Belt, a disk of icy bodies beyond Neptune, rather than forming where we find them. Gravitational nudges from the outer planets slowly drag them inward until they start looping close enough to the sun to grow a tail. Here's the fact that changes everything. Every time a comet passes near the sun, it loses material, ice and dust boiling directly off its surface, streaming into that iconic tail. Comets are not eternal objects. Halley's comet loses roughly 6 meters of surface material with every single pass. It is, quite literally, evaporating a little more each time we watch it. An object we associate with wonder is slowly dying in front of us, one perihelion at a time. And the source of these icy visitors is a region even stranger than the comets themselves. Kuiper Belt objects. A second asteroid belt, except this one is made of ice, sits far beyond Neptune, and dwarfs the main belt in every dimension that matters. Here's the reframe. The Kuiper Belt stretches from about 30 to 50 astronomical units from the sun, roughly 20 times wider than the main asteroid belt, and contains an estimated 100,000 objects larger than 100 kilometers across. Pluto lives here. So does Eris, an object once thought larger than Pluto, whose discovery in 2005 directly triggered Pluto's demotion from planet to dwarf planet the following year. Here's the fact that changes everything. The Kuiper Belt isn't debris in the way the asteroid belt is. It's a graveyard of building blocks that never finished accreting into a single 9th or 10th planet, preserved in a deep freeze roughly 40 degrees above absolute zero, essentially unchanged since the solar system's birth. When NASA's New Horizons spacecraft flew past the Kuiper Belt object Arrokoth in 2019, a reddish, two-lobed object shaped like a snowman, it photographed the most pristine, least altered building block of planet formation ever seen up close. An entire archive of the solar system's earliest moments, frozen and waiting 4 billion miles from the nearest reader. But the Kuiper Belt is not the edge. It's barely the beginning of what's out there. Long period comets and the Oort Cloud. This is where distance stops meaning anything intuitive. Here's the pitch. Long period comets take more than 200 years to complete one orbit, some take millions. They arrive from every direction in the sky at once, unlike short period comets, which mostly share Jupiter's orbital plane. That randomness is the clue. It points to a spherical shell of icy bodies surrounding the entire solar system, called the Oort Cloud. Here's the scale that should break your sense of proportion. The Oort cloud is theorized to begin around 2,000 astronomical units from the Sun and extend out to as far as 100,000, nearly a full light year and a half in radius. At that distance, the Sun's gravity is barely stronger than the pull of nearby stars. Some comets out there are only loosely tied to us at all. Here's the fact that changes everything. Nobody has ever directly observed the Oort cloud. Not one object in it has ever been imaged. Its entire existence is inferred purely from the math of comet orbits, a population trillions strong, theorized rather than seen, making up the largest structure in the solar system that we've never once laid eyes on. An invisible shell of ancient ice, a light year across, holding an untold number of frozen fossils from the birth of the sun, and we know it's there only because of the handful of stray members that occasionally fall. Some astronomers suspect the Oort cloud isn't even purely ours, because it sits so far out that neighboring stars can gravitationally graze its edges. It may be constantly trading material with other stellar systems, comets that formed around our sun drifting off to orbit someone else's, while their comets drift in to become ours. The outer edge of our solar system might not be a boundary at all. It might be a slow billion-year exchange with everything nearby. Most comets that fall inward burn quietly and swing back out. A rare few take the most dramatic path physically possible, straight at the sun itself. Sungrazing comets. Comets whose orbits bring them so close to the sun that survival is genuinely optional. Here's the pitch. The Kreutz sungrazers, the largest known family, are believed to be fragments of a single massive comet that broke apart centuries ago, its pieces still following nearly identical death-defying orbits. Some pass within a few 100,000 kilometers of the sun's visible surface, closer to the sun than Mercury ever gets, subjected to temperatures exceeding 2,000 degrees Celsius. Here's the fact that changes everything. Most sungrazers don't survive the encounter. They're torn apart by tidal forces or simply vaporized outright, their debris later burning up as meteor showers here on Earth. Solar observatories like SOHO have now caught more than 4,000 sun-grazing comets, meeting this exact fate live on camera, a decades-long highlight reel of objects committing suicide by star. Comet Ison in 2013 was supposed to be the comet of the century, predicted to blaze brilliantly across our skies. Instead, it disintegrated just hours before reaching its closest point to the sun, falling apart on live telescope footage in front of millions of viewers who had been told to expect a spectacle. The universe promised a show and delivered a funeral instead. An object diving toward its own destruction, live streamed for anyone paying attention. But even the sun isn't the strangest destination in this story. Some visitors aren't just far from home. They were never part of our solar system at all. Interstellar objects, the final category, and the one that broke the taxonomy entirely. Here's the reframe. Every object covered so far, asteroid, comet, Trojan, sungrazer, was born orbiting our sun. Interstellar objects were not. They formed around another star entirely, got ejected by some ancient gravitational interaction, and have been drifting through the emptiness between stars for possibly billions of years before wandering by pure chance into our solar system. Oumuamua was the first ever detected, spotted in 2017, tumbling through the inner solar system on a trajectory that made its origin unmistakable, too fast, too oddly shaped, on a path no solar system object could naturally follow. It was reddish, elongated, possibly 10 times longer than it was wide, and it accelerated slightly as it left, in a way that standard comet outgassing couldn't fully explain. Scientists still debate exactly what it was. Some proposed explanations ventured all the way to hydrogen ice or unusually shaped nitrogen ice before anyone seriously entertained anything stranger. Here's the fact that changes everything. 2 years later, in 2019, a second interstellar object arrived. Comet 2I Borisov, this time behaving exactly like a normal comet, complete with a visible tail, confirming that Oumuamua wasn't a one-time fluke. Interstellar visitors are a real, recurring category of object, not a single anomaly. Astronomers now estimate that at any given moment, thousands of interstellar objects may be passing through the solar system, most too small and too dim for any telescope on Earth to catch. Let that sink in. Somewhere out there right now, a fragment born around a star you've never heard of, orbiting for longer than our own solar system has existed, is quietly passing through the same space as Earth, and we will very likely never even notice it happening. So look at the full range. Stony rock and metal cores and carbon-rich chemistry sets spread across a belt too thin to look like the movies. Trojans locked in gravitational truces. Near-Earth objects that occasionally arrive with no warning at all. Comets shedding themselves alive on every pass, born in a Kuiper Belt we've barely sampled, and an Oort Cloud we've never directly seen. Sungrazers ending themselves on camera. And finally, visitors from entirely different star systems passing through and gone before we even finish arguing about what they were. Every single one of these objects is a survivor. A fragment of something that almost became a planet, or something that used to be part of one, or something that formed around a completely different sun and somehow ended up drifting past ours. The solar system isn't just planets and a star. It's an enormous, largely invisible archive of everything that didn't quite make it, and every few years, one more page of that archive drifts close enough for us to finally read it. Not bad for stick figures on a rock,